started with truth tables on Thursday, and so we're continuing with truth tables, but we've got a little bit more information. So just quick reminder of Thursday. We talked about our connectives, our disjunction, and our conjunction. So remember, conjunction is this one, like a capital A, that's and. And remember what we learned about our truth tables about conjunctions. If P is true and Q is true, and they use a conjunction, then the whole thing's true. And every other thing on the truth table is false. P is true, Q is true, the whole thing's true, everything else is false. And then our disjunction, that's the one that looks like this, and when we read it P or Q. And we learned about P or Q that if P is false and Q is false, then the whole thing is false. Everything else is true. So
That's right.
So that's what we did on Thursday. Now, we did it with just symbols, and we will start to add language in. Today we're going to add in language, but I'm going to be honest with you guys. In this case, it's a little bit hard. They tried to use simple statements for us to use, but the truth value of these, to be honest, is not we don't necessarily know the truth values of these. We will do some more a little bit later, where for like the ones we did before, where it was Paris is in France or whatever. Paris is the capital of Spain, whatever. Because you know for sure whether or not that's true or false. These are a little bit more difficult to determine whether they're actually true or not. Hold on, let me take a look. A new connective. So these were the first two connectives that we did. This one is our conjunction, that's and. This one is a disjunction, that's or. And we now are introducing some new logical connectives. And the first one we're going to do is what's called a conditional statement. You have done these in English, and you probably did them in geometry. A conditional statement is what we often call an if-then statement. And if we were reading it like this, it would say the statement is in the form of if P then Q. We write it with this little arrow, and the way we read that little arrow can be read as the word implies. So if you saw that, you would hear people say P implies Q. Or you could read it like we just said, if P, then Q. So the conditional statement P implies Q is false. Whoa, I don't know what just happened just then. Oh, I don't know why that happened. All right. The conditional statement P implies Q is false when P is true and Q is false. Otherwise, it's true. So they've given us a statement. P, I will go clean my room, and Q, Mom said I can go to the movies. So they're making this statement that if P is true, now, this is what I was saying about, we don't know if it's true or not, because we don't know whose mom this is, and we don't know if she said that they could go to the movies. But if Mom said that if I clean my room, I can go to the movies, if P is true, if P is true and Q is false. So I'm going to look on my truth table and I'm going to find that place. So on my truth table, that is given right here. P is true and Q is false. I just learned that when I have a biconditional statement that's written like this, P implies Q. If P is true and Q is false, then the whole thing is false. And every other statement is true. And in this case, it's easier for us to work them that way than it is for us to try to actually reason them out in our head. That is the entire point in a truth table, is because sometimes I really don't know, but I do know that these truth tables always work this way. And so if P is true and Q is false, the entire thing is false, and everything else is going to be true. So they asked me down here at the bottom to rewrite the sentences below to match the truth values. So they want me to match what's up here by using the word not. So this is 1, 2, 3, and 4. So if I clean my room, then Mom said I can go to the movies. That one's fine just like it is, because it says true, and the whole thing's true. So the second one says true and then false, so to make it false. So if I clean my room, then Mom said I need to make the second half of the statement, my Q statement, false. So how do we make something false again when we're doing this logic business? It was true to start with. How to make it false? Not. You use the word not. So if I clean my room, then Mom said I can not go to the movies. The next one, I need to make the P part of my statement false. So if I do not clean my room, then Mom said I can go to the movies. And then, oh, noise. You can go. And then number 4, I need to, what does it want me to do? Number 4, make them both false. So that would be if I do not clean my room, then Mom said I cannot go to the movies. Now, we know from our truth table that the second one is the one that's false. And the second one is false. The second one is false because that's what the truth table tells me. If I clean my room, then Mom says I cannot go to the movies. Well, that's because she said I could go to the movies. And so if I clean my room and then she says I can't go to the movies, then she lied. So number 2 is false. All right. There's a typo on this first page. P.S. So it says be careful not to confuse the conditional statement if Q then P with the conditional statement Q implies P. But this should really say don't confuse if P then Q with Q implies P. If I switch the letters, then it changes the statement. It is no longer the same thing as it was before. So for example, the conditional P implies Q formed from these two propositions would be if I drive fast, then I will receive a speeding ticket. Now, if I change those, and instead of putting P first, I put Q first, so I'm instead writing, it's still the conditional statement because it's still just an arrow, it's just Q implies P this time. So if I do that, that would be if I receive a speeding ticket, then I drive fast. That's not the same thing at all. Oh, I gotta a speeding ticket. Let me speed home and like, it's not the exact, that's not the same thing as the first one.
Oh, I did.
So switching P and Q, they don't necessarily, it doesn't work that way. And that's what they're saying. So, because those two statements have completely different meanings. So, these are called variations on our conditional statements, and the variations that we're going to be studying are the inverse, the converse, which is what we just did. Oh, hold on. I just put that in the wrong place. These go here. These are called variants. They're called logical variants. And the variants we're studying are the inverse, the converse, and the contrapositive. So let's look at
Central
contra positive. It does look like an E, sorry. All right, so let's write out symbolically what that would look like. So the conditional statement is just P then Q. So P implies Q, you use a little arrow. The converse is Q implies P. So, a little bit of information that you probably did not know. On Converse high tops, nobody has any on, do they? On Converse high tops, anybody know where the logo is?
on the side,
Which side?
left.
They're on the inside.
Yes.
They're inside on this, like in here. Which is backwards from all of their shoes that put their logos on the outside so you can see them. Because they're switched. That's why they're called Converse. Because they're swapped. No lie. Truth. So, it's only on the high tops though, because the low tops don't have the logos. You know, the round logo with the star in it. They're only on the high tops and they're on the inside of the shoe. Anyway, so converse just means you switch the Q and the P. Then there's the inverse. The P and the Q are in the same order that they were in, but we negate both. So it would be negate P implies negate Q. And in the contrapositive, we both switch them and negate them. So that would be negate Q, that's a horrible one, implies negate P. All right, so this first one, they just want us to take the original conditional statement that they gave me. If it is raining, then I will need an umbrella. So if it is raining or it is raining is my P. I will need an umbrella is my Q. And they want me to write the contrapositive. So they want me to negate Q implies negate P. So I do Q first and I negate it. If I do not need an umbrella, then it is not raining.
So it's just
Backwards and negative. Okay, we good so far?
Sure.
All right, now we're gonna do truth table. Oh, well, let's first look at our variance. I forgot we did that first. All right, so now they've given me 3. I'm gonna give you a second. If I walk 30 minutes every day, then I will have a healthy heart. That's your original conditional statement. So then they're asking you to match which one's the converse, which one's the inverse, and which one's the contrapositive. Take a second and read through them and see if you can find them.
Guess. That one, done and done.
my P is I walk 30 minutes every day. My Q is I will have a healthy heart. Converse means I'm switching them, so the Q should come first. So it should be if I have a healthy heart, then I will walk 30 minutes every day. So the converse is this one.
1 for 1 already.
Inverse is making them negative but leaving them in the correct order. So it would be if I do not walk 30 minutes every day, then I will not have a healthy heart. So that's that one. And the contrapositive is the only ones left. That's when you switch and negate. So it would be if I do not have a healthy heart, then I did not walk 30 minutes every day. All right, so far so good? Pretty easy? Okay.
We got it.
All right, so now we're going to construct the truth table. They've given me my P statement and they've given me my Q statement. But remember, we can do the table without the statements. The statements are just there because that's the whole point, is for us to be able to logically say whether something is true or false. So I've got, first thing I've got to do, I'm going to ignore this for a minute because I don't need it right this second. I really don't need it at all. We'll talk about using them later. But first thing I need to do is just negate Q. So if Q is true, then negate Q is false. And if it's false, it's true. So false, true. Okay. Now my next thing to do is I am now looking at P implies negate Q. So I'm ignoring this. And I'm looking at just this new conditional statement, P implies negate Q. And remember what we learned. If P is true and Q is false, then the whole thing's false. So that would be true, false, false.
Okay.
Everything else is true.
So just finding the opposite for all of them. Is that basically what it is?
That's what negating is.
They're all true?
Everything but the one that's
Yeah, I know. How are they all true then?
because that's the rule.
So do you just find the like?
Just the
So
first.
on the very first page we did this. Hold on. Is it on this page? Yeah. Hold on. On the very first page, here's the rule. If it is a conditional statement. So that's what we're looking for. We're looking for P to be true, for what it follows the arrow to be false, and then that means the whole thing's false, everything else on the truth table is true.
So we're just
the whole table is
trying to find the one that matches the
Uh-huh.
thing.
Yep.
Really what it is.
Yep. Okay, so let's look at this one.
Oh.
So first thing I need to do is negate P and negate Q. So negating P. Okay. Then I'm going to negate Q. And now I can ignore these first two columns because all I'm looking at is negate P implies negate Q. So take a second, see if you can figure out what's supposed to happen on your truth table.
I think you're good.
So if the second half of the conditional is false and the first half is true, then the whole thing's false. And everything else is true.
Get the whole thing wrong.
Okay, so now, before we go to the next thing, let's talk about the three connectives that we know and the rule for them. Oh, not A. It's not an A. It just looks like an A. That one. That's and. And what did we learn about and?
It points up.
True. It does point up. Good. True, true, true. That's what we learned. And everything else on the table is false. Then we learned this one. And on that one, which is or, and it's a disjunction, we learn false, 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 and everything else is true. Yeah? And then we just learned this one. Arrow. True, false, false. Everything else is true.
Oh, give me another one. I'm telling you.
Are we good? Yeah? Okay. Now, later in a couple of days, when we start to put actual I know they're putting statements on this page, but we'll put actual statements on it, and it'll start to make sense why you might need the logic table. Are y'all okay now on your connectives? These? Yeah? All right. So we got another one.
Can we start with the bottom one?
No, because you don't know it yet.
Oh.
Because it's a double arrow. Gotta learn it first. Okay, so if you look, this little arrow has 2 points on it, one going each direction. This is what's called a biconditional statement. If it has a 1 arrowhead, it's a conditional statement. If it has 2 arrowheads, it's a biconditional statement. Which makes sense, because the prefix bi means 2. And I have 2 arrowheads. So it makes perfect sense. So the rule for a biconditional statement is P.S., the way that we read a biconditional statement is P if and only if Q. So that's how you read it, if and only if. So the biconditional statement P if and only if Q is true when both are true or both are false. So it's true if they're both true, it's true if they're both false, and then everything else is false. So in this case, these are both true. So P if and only if Q is also true. And right here they're both false, so that's true. And everything in between is false. Yeah? So now you can try the one at the bottom, now that you know the rule.
I'm so much better.
I'm getting it now.
And the rule is, if they're both true, it's true.
True. Yeah. Yeah.
If they're both false,
It's true.
it's true.
Oh.
And everything else is false.
Ooh, I got it.
Got it? All right.
For now.
If it's FT, it should be TF.
Okay, let me give you the assignment.
Assignment?
Yeah,
No,
you got
what-
practice.
I had practice one from last week.
Well, it's not my fault you weren't here.
I was sick.
I'm sorry. You better
Yeah.
do the assignment if I can find the assignment.
Telling you, it's a sign.
Everybody just does it like
Ooh.
wasting it. It's like,
All my Wi-Fi low.
No, but
like 5 years. Can you use that?
What is this?
Everybody's like, oh, we can't do that. Oh,
Well, y'all hold on. I don't know what I did with them. I'll be right back.
that's like, can I do one? I just.
Oh, there they are.
And mine is
didn't even know
You just said anyway.
No, I
You
did
just
not.
said you.